Hello everyone. Today I am going to discuss about routing algorithms, which comes under the subject computer networks. What is a routing algorithm? A routing algorithm is a procedure that lays down the route or path to transfer data packets from source to the destination. They help in directing internet traffic efficiently. After a data packet leaves its source, it can choose among the many different paths to reach its destination. Routing algorithm mathematically computes the best path, that is least cost path, that the packet can be routed through. Classification of routing algorithms. The routing algorithms can be classified as follows: adaptive algorithms, non-adaptive algorithms, and hybrid algorithms. Adaptive algorithms. These are the algorithms that change their routing decisions whenever network topology or traffic load changes. The changes in routing decisions are reflected in the topology as well as the traffic of the network. Also known as dynamic routing, these make use of dynamic information such as current topology, load, delay, etc. to select the routes. Optimization parameters are distance, number of hops, and estimated transit time. Further, these are classified as follows: isolated. In this method, each node makes its routing decisions using the information it has without seeking information from other nodes. The sending nodes don't have information about the status of a particular link. The disadvantage is that packets may be sent through a congested network, which may result in a delay. Examples: hot potato routing and backward learning. Centralized. In this method, a centralized node has entire information about the network and makes all the routing decisions. The advantage of this is only one node is required to keep the information of the entire network, and the disadvantage is that if the central node goes down, the entire network is done. The link state algorithm is referred to as centralized algorithm since it is aware of the cost of each link in the network. Distributed. In this method, the node receives information from its neighbors and then takes the decision about routing the packets. A disadvantage is that the packet may be delayed if there is a change in between intervals in which it receives information and sends packets. It is also known as decentralized algorithm as it computes the least cost path between source and the destination. Non-adaptive algorithms. These are the algorithms that do not change their routing decisions once they have been selected. This is also known as static routing, as a route to be taken is computed in advance and downloaded to routers when the router is booted. Further, these are classified as follows: flooding. This adapts the technique in which every incoming packet is sent on every outgoing line except from which it is arrived. One problem with this is that packets may go in a loop, and as a result of which a node may receive duplicate packets. These problems can be overcome with the help of sequence numbers, hop count, and spanning trees. Random walk. In this method, packets are sent host by host or node by node to one of its neighbors randomly. This is a highly robust method that is usually implemented by sending packets onto the link which is least queued. Hybrid algorithms. As the name suggests, these algorithms are a combination of both adaptive and non-adaptive algorithms. In this approach, the network is divided into several regions, and each region uses a different algorithm. Further, these are classified as follows: link state and distance vector. Link state. In this method, each router creates a detailed and complete map of the network, which is then shared with all other routers. This allows for more accurate and efficient routing decisions to be made. Distance vector. In this method, each router maintains a table that contains information about the distance and direction to every other node in the network. This table is then shared with other routers in the network. The disadvantage of this method is that it may lead to routing loops. The optimality principle algorithm. The purpose of a routing algorithm at a router is to decide which output line an incoming packet should go. The optimal path from a particular router to another may be the least cost path, the least distance path, the least time path, the least hops path, or a combination of any of the above. The optimality principle can be logically proved as follows. If a better route could be found between router J and router K, the path from router I to router K via J would be updated via this route. Thus, the optimal path from J to K will again lie on the optimal path from I to K. Now let us consider an example. So consider a network of routers G, H, I, J, K, L, M, N as shown in the below figure. Let the optimal route from I to K be as shown via the green path, that is via the route I, G, J, L and K. According to the optimality principle, the optimal path from J to K with along the same route, that is J, L and K. Now suppose we find a better route from J to K, then say along J, M and K. Consequently, we will also need to update the optimal route from I to K as I, G, J, M, N and K, since the previous route ceases to be optimal in this situation. This new optimal path is shown with orange lines in the following figure. Shortest path algorithm. The shortest path algorithms aims to find the optimal paths between the network nodes so that routing cost is minimized. They are direct applications of the shortest path algorithms proposed in graph theory. Explanation. Consider that a network comprises of n vertices, nodes or network devices that are connected by m edges, transmission lines. Each edge is associated with a weight representing the physical distance or the transmission delay or the transition line. The target of shortest path algorithms is to find a route between any pair of vertices along the edges, so the sum of weights of edges is minimum. If the edges are of equal weights, the shortest path algorithm aims to find a route having minimum number of hops. Common shortest path algorithms. Some common shortest path algorithms are Bellman-Ford's algorithm, Dijkstra's algorithm, Floyd-Warshall's algorithm. Now let us discuss about Dijkstra's algorithm. Dijkstra's algorithm is a popular algorithm for solving many single source shortest path problems having non-negative edges in the graph. That is, it is to find the shortest distance between two vertices on a graph. The algorithm maintains a set of visited vertices and a set of unvisited vertices. It starts at the source vertex and iteratively selects the unvisited vertex with the smallest tentative distance from the source. It then visits the neighbors of this vertex and updates their tentative distances if a shorter path is found. This process continues until the destination vertex is reached or all reachable vertices have been visited. Now consider this below graph. Example graph. The algorithm will generate the shortest path from node 0 to all other nodes in the graph. Initially, we have a set of resources given below. The distance from the source node to itself is 0. In this example, the source node is 0. The distance from the source node to all other nodes is unknown, so we mark all of them as infinity. Now let us see the step 1. We have to start from node 0 and mark node as visited. As you can check in below image, visited node is marked red. Step 2. Check for adjacent nodes. Now we have choices. Either choose node 1 with distance 2 or either choose node 2 with distance 6 and choose node with minimum distance. So in this step, node 1 is minimum distance adjacent node. So mark it as visited and add up the distance. So distance becomes 2. 0 plus 2, 2. Step 3. Then move forward and check for adjacent node, which is node 3. So mark it as visited and add up the distance. Now the distance will be node 0 to node 1 to node 3, which is 2 plus 5, 7. Step 4. Again we have two choices for adjacent nodes. Either we can choose node 4 with distance 10 or either we can choose node 5 with distance 15. So choose node with minimum distance. In this step, node 4 is minimum distance adjacent node. So mark it as visited and add up the distance. Now the distance becomes 17. Step 5. Again move forward and check for adjacent node, which is node 6. So mark it as visited and add up the distance. Now the distance will be 2 plus 5 plus 10 plus 2, which is 19. Flooding. Another starting algorithm is flooding, in which every incoming packet is sent out on every outgoing line except the one it arrived on. Flooding obviously generates vast number of duplicate packets, in fact, an infinite number of unless some measures are taken to dam the process. One such measure is to have a hop counter contained in the header of each packet, which is decremented at each hop, with the packet being discarded when the counter reaches 0. Ideally, the hop counter should be initialized to the length of the path from source to the destination. A variation of flooding that is slightly more practical is selective flooding. In this algorithm, the routers do not send every incoming packet out on every line, only on those lines that are going approximately in the right direction. Flooding is not practical in most applications. For example, let us consider the network in the figure having 6 routers that are connected through transmission lines. Using flooding technique, an incoming packet to A will be sent to BCD, B will send the packet to C and D, C will send the packet to B, D and F, D will send the packet to C and F, E will send the packet to F, and F will send the packet to C and E. Now let us see the types of flooding. There are 3 types of flooding: uncontrolled flooding, controlled flooding, and selective flooding. Uncontrolled flooding. Here each router unconditionally transmits the incoming data packets to all its neighbors. Controlled flooding. They use some methods to control the transmission of packets to the neighboring nodes. The 2 popular algorithms for controlled flooding are sequence number controlled flooding and reverse path forwarding. Selective flooding. Here the routers don't transmit the incoming packets along those paths which are heading towards approximately in the right direction, instead of every available paths. Difference between static and dynamic routing. Static routing. Static routing is also known as non-adaptive routing, which doesn't change the routing table unless the network administrator changes or modifies them manually. Static routing does not use complex routing algorithms, and it provides higher, more security than dynamic routing. Dynamic routing. Dynamic routing is also known as adaptive routing, which changes the routing table according to the change in the topology. Dynamic routing uses complex routing algorithms, and it does not provide high security like static routing. When the network change occurs, it sends the message to the router to ensure the changes, then the routes are recalculated for sending updated routing information. Thank you.